Hello everyone and welcome back to our channel. In this video we'll be talking about the theorem of Pythagoras in our Euclidean geometry playlist. So the theorem of Pythagoras is a theorem or an axiom that has already been proven years ago. And all we need to do is learn how to use it and not how it was proven and how to prove it. So let's have a look at how it works or how we use it to answer questions and determine distances and all that. So before we go into it, we always need to know this point. In order for you to use the theorem of Pythagoras, you always need a right angle triangle. You can never use the theorem of Pythagoras on any triangle that is not a right angle triangle. So with that being said, I just want to give you the properties of, or the basic things of, a right angle triangle. In a right angle triangle, the side opposite the 90 degree, in this case is the B, is always the largest side, is always the bigger side, or the side that has the greatest length compared to side A and side C. So yes, let's see how we can calculate b squared if we are given. So b squared if we are given a and c. Let's say we are given a to be a value and b to be and c to be another value. How then do we calculate the hypotenuse, which is b squared? So it's b squared is equals to, because b squared is bigger than all of them, that means if we add a plus c, it should give us b. So a squared plus c squared will give us b squared, and this is the Pythagoras rule, everyone. So now if you want, let's say they gave you a and they gave you the hypotenuse, which is b. They gave you a, side A, and they did not give you c. How would you calculate c then? You would then say c to the power of 2, or c squared is equals to, so we're making c the subject of the formula, so it's going to be b squared, which is the hypotenuse, minus a squared. So this a will go that other side and c squared will be left on our right, and on our left there will be b squared minus, so b squared minus a squared, and that's how you do it. And so let's say we were given side B, which is our hypotenuse, and we were given c but we're not given a. Then how would you calculate a? You would say the following. So you'd say a squared, and if you leave a this side and we put c that side, so it's going to be a squared is equals to b squared, so it's equals to b squared minus c squared. So what am I trying to say? I'm trying to say this is the basic rule for Pythagoras theorem, but this is when we need to calculate the hypotenuse. What happens if we're given everything else but we are not given c? So we're given b and a and we're not given c. Then we make c squared the subject of the formula. Then that means we'll be taking the hypotenuse squared minus the other value that we are given squared, and that will give us the other side. So this is how you calculate or you use the Pythagoras theorem. So let's have a look at some examples to better understand this concept and these formulas. So in this example, or in this question, we are asked to solve for z. So this is how you'd write it. The formula says z squared. So remember, we're using b because our side was labeled b, but at this moment we are given z as the hypotenuse. So z squared is equals to, because it's the hypotenuse, then we add everything because it's always going to be bigger. So we add our 4 squared, so 4 squared, plus we add our 3 squared, and we get that 4 squared is equals to 16 plus 3 squared is equals to 9 is all equals to 25. And if we take the square root of 25, so square root of 25, we get our answer to be, or our z to be 5. So our z in this case is 5. So let's substitute that right now and move on to the next question. So 5. In our next question, we are also asked to solve for x. But in this case, as we can see, our hypotenuse is the side that is opposite our 90 degree. And in this case, we are already given, which is 6. So let's write our formula and then we'll take it from there. So our formula says the hypotenuse, which is 6 in this case. So 6 squared is equals to 2 squared, so any of the sides first, plus, because addition always gives us or results to the same answer. So 2 squared plus x squared is equals to, then we need to solve it. And we know that 6 squared is 36 and 2 squared is 4 plus x squared. We leave x this side and we take 4 the other side, so it's going to be 36 minus 4, which is 32, is equals to x squared. And if we solve for x, so 32 square, so let's say square root of 32, we get, there is no square root of 32, so we'll get a surd number, or a number in surd form. So square root of 36 of 32 is 5,66. So our answer is 5,66. So this answer will be 5,66. And can you see from the previous example, the hypotenuse was larger. So the hypotenuse was bigger. And in this case, the hypotenuse is still bigger because our x is 5,66 and our hypotenuse is 6. Let's have a look at our next question. So in this question, it says, determine if two triangles are congruent. Use the result to find x, angle y, and z. So side x, angle y, and side z. X and z, okay? So we first have to prove if they are congruent. And if they are congruent, then we can further go into determining the x, y, and z. So if you recall from our previous video, we said there were 4 conditions to congruency. And the first one was the 90-degree hypotenuse and side condition. The other one was the side, side, side. The other one was the side, angle, side, and the angle has to be included. The other one was the angle, angle, side. Looking at this, it definitely can't be side, 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 because in this case we only have 2 sides. We only have 1 side, in fact, because our other side is an unknown. And in this case we have 2 sides and our other side is an unknown. It definitely can't be included angle. Well, maybe that's a possibility, but the one I can surely see in this case is the right hand 90-degree hypotenuse side. So let's see if we can solve it using one of the conditions. So in this case, we can start off by working with the unknown angles. So this is how we would go about it. So let me just write it there so that it's clear. So let's deal with the first triangle first and let's label it. So I, H, J, and then that's J, K, L, maybe. Yes. So let's say in triangle, in triangle HIJ, we have that 55 plus y plus 90 degrees is equals to 180 degrees. Sum of angles in a triangle. So sum of angles in a triangle. And so our y is equals to, sorry about that, y is equals to 180 minus 90, so y is equals to 35 degrees. So this y will be 35 degrees. Let's just enter that, 35 degrees. And in this case, we also know that if we say 180 minus 90 is 90 minus 35 is 1 is 55 degrees. So now we have all the angles, and let's see if we can solve it using anything to do with angles. So the one that can do right now is either write 90 degrees hypotenuse side or angle side. So let's have a look at angle side. So we are going to say JIH. So let's say angle I. Angle I is equals to angle K. Why? Because it's proven. Let's write proven right there. Then we have the 90 degrees, right? So let's write that down. So angle H, I'm just going to write H for now. Angle H is equals to angle L. Why? Given. We are given that they are 90s by that symbol or that box symbol right there. And then we are also given that HI, so line HI is equals to 3 and is also equals to LK because we are given, or KL. We are given that also. We are given, and because we have 3 conditions or 3 statements, we can conclude that because of angle, because the first one is angle, the second one is also angle. So angle side, and this one is the side, the one that has a 3. Then that means, let's write it down like that. So that means triangle HJI is congruent to triangle, and I'm trying to label them in the correct order. So L matches with H, right? And this J, which is 35, matches with the J there, and I matches with the K because it's 55 degrees. That means yes, they are equal. Because I don't have enough space, I'm going to rub this off and then continue to the next statement, because they say determine if 2 triangles are congruent. We've determined that. Use the result to find x, angle y, and z. So let's do that now. So if we were to determine x, we've just said that these triangles are congruent, meaning they're exactly the same. So looking at this side here that's opposite the 90 degrees is 5. That means here our z would also be 5 because they're exactly the same. 5. And if this angle is 5 and this angle is 3, we need to get that angle so that we can get x. We've already gotten y from our previous congruency proof. So we are only left with x, and to get x we use Pythagoras, because looking at triangle, so in triangle JKL, so if we look at this triangle here on my right, we can surely say that the hypotenuse, which is 5 squared, is equals to 3 squared plus x squared, and we solve for x by putting x alone, so we're going to leave x this side on my right, and it's going to be 5 squared minus 3 squared, so 25 minus 9 is 16, and we can see that our x, if we say square root of 16, is equals to 4. So our x is equals to 4. So x is equals to 4. Y, angle y is equals to 35 degrees. And z, so side z is equals to 5. And we've used, so whenever you write this statement here, which is pyth, you must always give your reason as pyth or Pythagoras theorem. But pyth is good enough. So thank you guys for watching. See you in our next video as we tackle some more questions. Very interesting and very entertaining. Thank you guys for watching. See you in my next video. Bye.